the house currently has 3 heat pumps. All of them are 2-ton. Did that instead of zoning originally, so we have one 2-ton that does the living room, extra bedrooms and bath down here. And you see you have this step down. One air handler is on this side of the step down and one air handler is right on the other side. So there's a steel beam holding up the various floors here. So there's the ductwork on this level is up against the bottom of the floor joist, as is the ductwork down here, but I have to get beneath this steel beam somehow to get to this other zone. So what I'm going to do is fabricate a piece of trunk duct with 2 8x20 ducts going each direction with zone dampers. Okay, here's the air handler. I pulled it apart in 2 sections. It's so tall it's kind of hard to see what I'm doing. I've got to turn this or modify this coil, put the drain pan on the opposite side and change a couple of the sheet metal pieces for left hand horizontal is the way it'll be under my house. But I like the neatness of the TXV and everything. It's easy to get to when it comes time to replace that TXV. It won't be around on the side like some of them are. Everything's right up front and easy to get to. This is the blower section. Of course, a variable speed ECM motor, communicating control board. The outdoor unit connects to it with four wires. Then I'll have 4 wires leaving here and going to a zone panel, and then 4 wires leaving the zone panel going to the comfort sink thermostat. Heat kit goes back there. It's a special heat kit for this particular model air handler. Nice little aluminum bracket for the breakers. Once we get power on it, you plug this up and then you have to actually program it to tell it how many stages of heat that you have. But what I'm going to do today is this discharge is 11 by 19 3/4. So what I've got to do, of course, it's going to be laying down flat. So it'll be 11 inches deep and right at 20 inches tall. What I'm going to do is make me a trunk duct that comes off this thing, a plenum, that I can go both directions to the 2 different zones that I'll be going to. Okay, here we have a piece of just stock 10-inch by 24-inch trunk duct. Bought a factory end cap and stuck on it. What I'm going to do is, it'll be standing upright down in the crawl space, about like what you see here. I am going to connect an 8x20 duct up here, which I'm making the actual opening for 8x26 duct, because what I will do is take one of these reducers and put it on my 8x20 duct to allow the air to be able to turn into this branch duct easily. Actually, the majority of the air is going to be probably coming through this duct most of the time. That's the side of the house that I actually use. So the other side, the zone will stay off most of the time, or not off, but at least at a higher temperature. So once this thing's set in here like this, you'll have this duct coming out going to the, what I would call my main living area, which will be right beneath the floor joist. On this side, I'll be coming out the same setup down low, because I need to miss this steel beam that we'll see when we go up under the house. So that will be the other transit, or the other branch duct that comes off. Then what will be left is to adapt this 10 by 24 duct to that 11 by almost 20 coming off the air handler. I'll build a transition piece. It'll probably be a couple of feet long. I'll look and see. I've got to put a discharge air temperature sensor in this duct for the zone control, so I'll make sure how far they want that from the branch ducts and also the fan. but I'll build a transition piece here. What I'll probably do is line up the top and this side, which will be the back is the way I would call it if I was at the air handler. And so I'll make this be the common side, and then I'll make my transitions on the front and bottom so that it adapts to the air handler. And I'll do as much of that stuff up here as I can so I'm not fooling with it under the crawl space. And of course, once you get your hole cut, you can take a bending tool and bend for your drives and your S-locks. You notice I stayed a little bit from the edge of this duct. I needed as much height as I could get, but I could have cut this all the way up against the corner. However, it would have made the duct less rigid and stiff. And by the time I get it carried under there, I don't want to, mess it up. So if you can leave a little shoulder there, it makes it a lot stiffer. Then, of course, this is what this piece winds up looking like with this little reducer put on it. Actually, be more of an increaser on this particular application, huh? So what I'll end up doing, I'll screw all this together and seal it. It will connect. Of course, one will connect to this side. Then I'll have the exact same piece coming off this side over here, going to the second zone. Okay, this is the trunk duct with the two supplies coming off of it now, kind of mocked up here on the floor. Thing's about 9 foot in this dimension, 4 foot in this dimension, and about 24 inches tall, so I can actually get this under the crawl space from here. So what I may go ahead and do is screw everything, mastic everything, insulate everything, and it'll be so much less to do when we get underneath the house. Again, what we have is a 10 by 24 trunk duct and two 8 by 20s servicing the individual zones. We flared this out like we talked about. In each one of these 8 by 20 branches, it's going to have a zone damper. That's a Honeywell ZD damper. This particular one is set up right now for spring open and powered shut, which is how I will leave it. That way when a zone is not calling, it will turn it off, otherwise it'll remain open. I made a transition to go from my air handler to this trunk duct. The length of the transition, I basically decided to make it the length I did based on this temperature sensor. The only limitation they had in the manual was this temperature sensor should be 19 inches away from the air handler. So that will put it right in this general area. It's adjustable so that you can put it, the tip of it halfway into the duct. I'll have to adjust this one very slightly. I won't put it in until I'm underneath because I don't want to take a chance on damaging it. But all in all, the hard part is about over. Okay, this is the top part of the air handler. Again, I take it apart to make it easy to work on. This is my transition. I made it out of 3 pieces of metal. This is the only right angle on it, so I used it, bent a piece of metal and made that to start with. Then I could measure the actual lengths of these angles in order to get the right size piece of metal. So I've got it screwed to the flange on the air handler already. What I'll actually do is use mastic tape right here, and then I'll actually put mastic on all the other seams on it. And I will insulate this portion, leaving this joint right here to be made underneath the house and attached to the trunk duct over there. Down in here, you have the control board and the breakers. I went ahead and mounted a transformer in here for the zone dampers. I just pulled power right off this main 30 amp breaker for it. We'll have these two 24 volt wires. I've got to pick up a pressure switch out of this air handler anyway to go to the zone board. So what I'll do is run a 4 conductor wire, pick up the 2 leads off the pressure switch, pick up the 2 24 volt leads for the zone damper, control board and dampers, and run them up to where I mount my zone panel. Okay, once I come out from under the beam, I'm going to need to get back up underneath the floor joist. The way I'm going to do that is with a 45 transition. The only thing my supply house has are 90 hard 90 fittings. So what I've done is just cut out some pieces here. I got to make 2 of these, so I will get these prepped to put together and show you what they look like then. And here we have the individual pieces made up, ready to put together. I don't have a Pittsburgh machine or anything, so I just have to basically I clamp this stuff together and run screws in it and then seal everything with mastic. Okay, I'm going to put the pressure switch on so the zoning system will know if they're not getting enough air across the coil in heat mode. Just picked up this T. I'll put it on here. The pressure switch will probably end up going right here, and the equalizer line will just connect to the top. There'll be no valve core between the line and the equalizer. However, I'll leave a valve core on the pressure switch just in case I ever need to change it. Okay, I'm putting a little nitrogen back in the coil. Of course, it'll let the holding charge off of it when I remove the equalizer. I've got a valve core in this particular port, so it'll hold the nitrogen in until I can get the pressure switch screwed back on. And there we have it. I will extend these wires. I'll probably go ahead and maybe solder a piece on them, but I will bring them around and up the edge of the air handler on the inside up into the control box, probably through this hole here where I can make my connection to the thermostat wire going to the zone panel. Okay, I'm going to use a little solder and some heat shrink pieces to make this connection inside the unit, and it'll be good as factory. And there we have it. This is the discharge air temperature sensor that's going to go in the supply duct. It has to run up and connect to the zone panel as well. But I was looking at it, and it looks like this green wire has been pinched pretty badly somewhere along the way. I bet it's nearly broke if it's not already. So what I'm going to do while I've got my heat shrink stuff out, I'm going to go ahead and put a 2-conductor thermostat wire on it down here close past that break, and I will run that all the way to the zone panel in a separate cable. Since it's actually carrying resistance, all the other stuff's carrying, with the exception of the bus, which will be a separate 4-conductor cable anyway. All the other stuff is carrying voltage or just a make or break connection. So I'll go ahead and put the 2-conductor wire on this, and I'll be ready to drag it up to the zone panel when I get ready. Here is the return plenum box I built. What I'm going to do is put a 16 coming in the end of it, and then there'll be a 14 coming out the side or the back. That's what it'll actually do. Currently I have a 14-inch and a 12-inch, but I'm going to enlarge them. I don't know that I'll get them done before I have to have this thing online. The factory representative is coming in a couple of days to start it up, so I'm going to have to get it in there. But what I'll do is go ahead and plan on the 16 and 14, and then I can put a reducing fitting on it if I need to connect it up to the existing 12 and 14 that's down there temporarily to get it started up. Okay, I'm gonna go ahead and pump this one down, and so I can cut the air handler loose on the inside. I just turned it on inside, so I won't have to fool with opening up the cover or nothing right now. It's actually got less use on it than either of these other two, so I will pump it down, seal the ends up good, and store it somewhere for when one of these others go out. Probably what I'll do, this one will be my garage unit, which I won't use all that much, but that one does the upstairs. I'll probably replace it next, and then if nothing happens yet before then, I'll have 2 extra ones for the garage. So I should be set as far as R22 2-ton heat pumps for a little while. Okay, she pumped her down into a vacuum, so I've got the king valve sealed off. I can go inside now and cut the air handler loose. Okay, here we are in the crawl space. What we're going to do is cut this one loose. Should be a seam right there between the 10 by 16 duct and that transition fitting. So I'll take the ductwork loose at that seam. It's got a little 12-inch flex running around the back that's tied into the end. I'll take it off, cut the line set loose, pull the power out, thermostat wire out, slide it out of here. Blower wheel don't look bad for 14 years. Like I say though, this one didn't run a whole lot. Okay, I've got the old air handler out that was in my way, and I can measure how high the actual existing duct is, and I know that I know that I need to drop it 10 inches to get under that beam and tie back into my insulated piece there. So using my awesome geometry skills I learned from Miss Kate Enzer at a little school called UNACA many years ago, I figured the hypotenuse and made me a piece of duct to give me a 10-inch drop on those two 45-degree fittings that we made. So I'm going to put all this together, probably go ahead and seal it and insulate it before I drag it under there. Okay, got the new air handler hanging here right next to the old air handler. I'll have to take this one out before I can put my coil in and stuff. It's just too tight to do anything. So got this big piece of trunk under here and tied to the air handler and tied to the duct on the other zone. This is coming toward me. It'll come straight back here and turn and tie back into that trunk duct over there after we remove that piece in the 90 coming off of that air handler. These runs here will get shortened up and put in the new trunk duct. That's a 60 amp circuit. I'll take it out and pull it over to the boxes down that way, so I'll pull it over to this air handler. I also need a 30. I got 15 kW in this one, so I'll have to run a new number 10 back to the panel for the extra auxiliary heat. I'll have to put me a light over here in front of this one because this ductwork's going to shield the lights I've got down here now. May put me a fluorescent right over my head there. Make it very light back in here. So I'm going to pick up some tools and call it a day and start back on it tomorrow. Okay, getting ready to pump this one down so I can remove it and start working on assembling the new one. I'm going to have to shorten these two supply vents as we talked about, so I'm going to go ahead and cut them loose and let it blow some cold air under here for a few minutes while I'm getting ready to pump it down. I'm just going to pump this guy down using my Z manifold. I'm going to leave this unit. I'll extend the line set on out to the garage after I get through with this install and get me some cooling out there. Shut off the liquid valve, it's starting to drop. I've got the suction valve started. Got my disconnect open so I can pull it out when it gets down there. You can hear the compressor start to strain. And she's out. So now I can go in and cut the line set loose from the air handler and tear it out. Yeah, I got all the pieces of the trunk duct on this side of the beam connected up now, so it's all in place. I will mastic all of these seams and then insulate it. I was going to possibly insulate it up in the garage, but it was just too hard to handle by yourself. Insulation doesn't make it a lot heavier, but it makes it a lot harder to hook together, so it'll be easy to insulate under here. Pretty much stand on my knees and do it. So I'm going to drop back over here at the air handler. I've got a fluorescent light I'm going to put in. I'm waiting on some bulbs to be delivered, and I can start hooking up the control wiring for it and the high voltage. Well, my helper got off from her day job and picked me up some bulbs, so I can see now. And as a side benefit, I put her to work. Okay guys, getting ready to braze in the outdoor unit here. Got my nitrogen flowing, rags around the valve. That'll be fun to service one day, huh? It's the way of the future though. Embrace the technology. Okay, the outdoor unit's welded up. I got the inside lines uncapped. I've got to go in and make a few bends on it and connect it to the air handler. I've cut off about 6 inches out here, maybe 7, and I may cut off just a couple inches inside, but that'll be a 50-foot line set minus those 2 little pieces I cut off. And if you don't have one of these nitrogen regulators, I highly recommend them. You can, I've still got it on. Just set it on braze and it flows the perfect amount. I usually turn it on to purge or even test if it's an open line on the other end, just to get the line full of nitrogen to start with, and then leave it on braze, and it just flows a little bit through the whole time you're working. Okay, underneath, always remove the bulb, even though I wrap everything with a wet rag because I'm chicken. But I used a little street L right here. Had to take off about 2 inches pipe in here, so it should be real close to a 50-foot line set. So I've got nitrogen coming through here. I will braze these 2 joints up, and then I will go out and switch the nitrogen to the other side, because I will probably sweat my dryer on kind of horizontal here and then bend it down. It'll just be a lot easier to do without getting the flame up close to the cabinet. Okay, out with the 14-inch return and in with the 16-inch. Got the mastic on it, getting ready to slip it up on there and put some bands and screws in it. Okay, wiring up the damper control module, or the zoning panel as I would call it, here in the I got it up here in a pantry closet. I've replaced all of the thermostat wires with 4-wire cable, so I wouldn't have to worry about noise on those additional wires. Plus the original install had like 22 gauge thermostat wire, maybe 20 gauge, and this thing really wants you to have 18 gauge. So I've got my wires numbered that I've ran down underneath the house to the unit, so I'll know what's what. And I'm keeping a list of what I'm hooking up on which cable and which wire. So make a couple more connections here, and then I can put the zone sensor in the actual ComfortSync thermostat, about the size of a small iPad. I can hook it up and have everything ready to go. Okay, so over on the left side here is where you hook up your zone sensors. So since I only have 2 zones, I'm only using one of these terminals, and it's the regular 4-wire bus. The 2-wire connector I got here is for my discharge air temperature sensor. Goes on those 2 screws. I brought a 4-conductor cable up from the air handler here. 2 of the wires is for my pressure switch that I put on down there for heat pump operation. Wants to make sure that it doesn't close off too many zones when it's heating and build up the pressure too high. And then the other 2 wires in that cable are for the additional 24-volt transformer I installed in the air handler to run the control panel and the dampers themselves. Back over on this side, this is where you would hook up your dampers. So I have 2 dampers, zone 1, zone 2. So I'm using one 4-conductor cable, which I'll run to one damper and then jump over to the other damper. They're only about 7 or 8 foot apart. So that's the actual damper connections there. Up here at the top This connector is called thermostat, which is going to the actual ComfortLink thermostat. You have your R, they call it a data plus and a data minus, and then a common. And then beside of it here it says indoor unit. So it's just a 4-conductor cable that runs between this panel and the actual board in the air handler. And then the outdoor unit connects to the panel in the circuit board that's actually in the indoor unit, and I just have to run a 4-conductor cable between the indoor and the outdoor. So I'm going to snap the cover on this and move over and put on the actual ComfortSync thermostat. The base plate goes in the standard hose and 4-wire connection, and you're pretty much done. And she just snaps on. Hopefully we'll get a shot of it when we get it up and running Thursday. Here is the little zone sensor that goes down here in zone 2. It's fairly small. You know, there's my hand, you know. So, well, 4 fingers wide. But I would actually wouldn't have minded it to be just a little bigger. It's kind of hard to wire. It's got little stabs that you push the wire up in. But it went together okay, and it's on there now, so hopefully I'll never have to remove it anyway. There it is compared to a double gang light switch. Well, the following day was startup day, and I didn't get to get any video. No one around here really wanted to take the classes on learning how to install these things. So Allied Air actually sent one of their training guys up to my home to actually start this system up and go over it with me and basically certify me to put in variable speed systems. Here's some screenshots of the thermostat after we started it up. You can see the diagnostics, also the phone app. That's my iPhone. It's quick and easy to use. This is kind of a neat thing. I kind of like the look of the thermostat, but if you had someone that wanted it to be less obtrusive, you can take a picture of the wall and upload it to the thermostat on the website. It actually makes the thermostat kind of blend in with the wall. I know it's hard to see through the camera here, but and then of course all you got to do is touch it, and you're ready to go. Okay, it finally cooled off enough to get to use the heat on this thing. I've been waiting to turn it on and see if it worked like I hoped it did. And so far so good. If you notice the third line down, it says the heating rate is 72%. That's the percentage of heat out of that 4-ton outdoor unit that the thermostat or the control is trying to get. You see it just jumped up to 77%. What's significant about that is I'm only heating one zone right now. And that one zone is only using like 700 CFM of air from the air handler. So we have I guess a 44% of the 4-ton unit inside. And right now we have 77% of a 4-ton unit outside, which means I'm getting a lot warmer discharge temperature than I would have gotten out of the old 2-ton heat pump. Had it been on here right now, I would have been getting 100% indoors and out. But 100% of 2-ton is less than 77% of a 4-ton. And I'm watching it. It may continue to climb. It just jumped up to 77% as we started talking on this video. It started out at like 42%, then jumped up to 61%, 66%, and now 77%. So I think it's going to do what I hoped it would do, which is give me more heat in the winter, or a warmer heat, than a traditional single-speed heat pump. I've been pleased with how the unit's performed. I've had it in for several months now. You can see I'm keeping this main zone that I'm actually living in at 69 degrees. If I go over to the lower level zone, it's on 64 degrees because the system is off. Even though the house is very open, it still keeps a temperature difference between the two if I have that one zone damper closed. I'm convinced that this unit could probably heat my entire house if I could add the upstairs to a zone. As we talked about in the beginning of the video, the air handler is actually under the floor right here. I have some closets right on the other side of that little powder room that I could go up through and get into the corner there where I have just kind of some dead space. There's an art niche, and up into the attic of this upstairs. I may go ahead and do that just because I'm curious if it will work or not, and you know how good it'll do. I went ahead and picked up a zone sensor just in case I want to try it. The only thing stopping me from doing it would be I kind of like the idea of having two systems just in case one goes down, you still have some heat or some cool. But from a standpoint of just wanting to know how well it would do with one system, I would sure like to try it. So I'm pondering doing that. If I do, I'll get some video of that and let you know how it goes. But in the meantime, it's taking care of the space that it's heating and cooling now great. And I haven't really had enough electric bills to know if I'm doing any better or any worse on it. But I'm sure it's a absolute excellent system anytime you have a zoning situation, because you're not bypassing any air. You know, I've all kinds of systems out there that have a 4-ton heat pump, and they wind up on one zone to a sunroom that's got 200 CFM going to it, and the rest of the air is bypassing. So it's going to be a lot better system for anytime you have a zoning situation. And I'm sure it's a good system all the way around. I don't know that I would put it in every person's home. I think there's specific applications for this type of technology right now. But I'll keep you posted if I have anything good or bad to say about it in the future. Thanks for watching.